Hello everyone, welcome back to study with me. This is another lecture. Here we are going to solve the numericals based on resistors in parallel. So we have already discussed about the resistance in parallel in the previous lecture. Please go through it if you have not seen it yet. So this is the numericals based on the previous lecture. Okay, so let's start with. So the question is, you need to find the current drawn from the battery by the network of 4 resistors shown in the figure. Okay. So what you need to find out is the current value. You need to find the total current of the circuit from the battery, in the sense the total current. Okay. So the battery value is given as 3 volt. So this is the total current. This is what you have to find out. And we have 4 resistors connected here. Okay. So let us find out. So just look into this diagram. Analyze the diagram first. Okay. So can you see this 10 ohm resistor and this 10 ohm resistor and this 10 ohm resistor? These 3 10 ohm resistors, how are they connected? This resistor, immediately after this resistor, this one is connected, and immediately after this one, this is connected. So how are they connected? They are connected in series. So we can write R is equal to R1 plus R2 plus R3. Right? So here the resistors are 10 plus 10 plus 10. So we will get the total value of resistors are 30 ohm by calculating these 3 resistors, because 3 are in series and total resistance is equal to adding all the 3. So 10 plus 10 plus 10 gives 30 ohm. Now let us redraw this diagram. So we got the equivalent of these 3 resistors as 30 ohm. So let me redraw it. So this is the 30 ohm. 30 ohm is the equivalent of these 3. And how was this one connected? You can see this point, right? So here this starts one resistor, and at this point starts the another resistor. Okay, so they are connected in parallel. So I can say this one is connected in parallel. Okay, so this is the 10 ohm resistor connected in parallel, and we have the voltage source connected to it. Okay, we have the voltage source connected to it. So this is the voltage source 3 volt. Okay, so we have redrawn this diagram. So we need to find out what is the total current, right? So since these two are connected in series, at this point what happens? The current gets divided into I1 and I2, right? The currents gets divided into I1 and I2. Okay, so that is not necessary, but just keep in mind. Okay. Now, what you need to find out is the total current alone, right? So for that, we know by Ohm's law. What is the equation to find out the current? By Ohm's law, we know that V is equal to I into R, right? So we know what is the value for voltage. We need to find out I. So I is equal to V by R. But we don't know what is the equivalent resistance. So we need to find what is IT. Right, so total current IT is equal to V by RT. So we need to find what is RT. So RT, so resistance in series, resistance in parallel, right? The total resistance RT will be equal to what? 1 by R1 plus 1 by R2. So we can write RT is equal to 1 by, what is the value for resistance R1? 30 plus 1 by 10. Now taking the LCM, we can write 10 plus 30 divided by 30 into 10, right? Or we can write 40 by 300, or we'll get the answer as 7.5 ohms. The resistance, total resistance value, we will get it as 7.5 ohms. How we will get 7.5 ohms? So this is the 0 and 0 gets cancelled, right? So we will get it as 4 by 30. So very sorry, this is 1 by RT, right? 1 by RT is equal to 1 by R1 plus 1 by R2. 1 by RT. Okay, so how can we write 1 by RT is 4 by 30. So how can we write RT? RT is equal to 30 by 4. 30 by 4 is what? 7.5 ohms. So now find out the answer for current. I is equal to V is 3 and RT is 7.5. So you will get the value for total current as 0.4 amps. Okay, I hope this is clear. So these 3 resistors are connected in series. I have added it up. Okay, and I have redrawn the diagram. 30 ohm and 10 ohm. These two are connected in parallel. So 1 by RT is equal to 1 by R1 plus 1 by R2. So I got the value for RT as 7.5. Substituting in this equation, V value is 3 and RT value is 7.5. So I got the total current value IT is equal to 0.4 amps. Okay. Okay. Now let's move on to the another question, a simple question. So for the electric circuit given below, calculate the equivalent resistance of the circuit. Very simple. Okay. So this is the circuit given. We have 3 resistors connected. So this is the total current I flowing in the circuit, and this is the total voltage is given as 6 volt. So how are these 3 resistors connected? All the starting points are connected to one particular point, and all the ending points of the resistors are connected to one particular point. So they are connected in parallel. So resistors in parallel. So what is the equation to find out the value? 1 by RT. Total resistance is equal to, here we have 3 resistance. So 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by RT is equal to 1 by, what is the value for R1? 30 plus 1 by, what is the value for R2? 10 plus 1 by R3 value is 5. Okay. So we can take 30 as LCM. So we will get 1 plus 3 plus 6 divided by 30. That is 10 by 30, which is equal to 1 by 3. So we will get the answer 1 by RT is equal to 1 by 3. Therefore, RT is equal to 3 ohm. Okay. RT is equal to 3 ohm. So very simple, direct substitution. You have 3 resistors connected in parallel. You just need to find out what is the equivalent resistance. Use the equation 1 by RT is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Substitute the value. The value will get 1 by RT is equal to 1 by 3. So RT will be equal to 3 ohms. Okay. Okay. Now let us move on to a very important question. It's a very, very important question. Okay. See, a wire of resistance R1 is cut into 5 equal pieces. Okay. These 5 pieces of wires are then connected in parallel. So if the resultant resistance of this combination is R2, then find the ratio of R1 by R2. Okay. So we will solve it line by line. A wire of resistance R1 is cut into 5 equal pieces. Right. Wire of resistance R1 is cut into 5 equal pieces. So let us consider, okay, let us consider the length of the wire. The length of the wire is not given in the question. So let us consider the length of the wire is equal to L. Let the length of the wire will be equal to L. So what is given? The resistance of this wire is R1, that is given. The wire is cut into 5 equal pieces. Right? The wire is cut into 5 equal pieces. So if the total length is L and if I cut this L into 5 equal pieces, what will be the length of each piece? It will be L by 5, right? I have a wire of length L and I cut this into 5 equal pieces. This is 1 piece, 2nd piece, 3rd piece and 4th, 5th piece. So each will be L by 5. So I will be having 5 pieces of each length L by 5. Right? 5 pieces each length L by 5. Now, the important thing you need to remember is we have studied the equation of resistance as R equal to rho L by A. Right? Where rho is the resistivity, L is the length and A is the area. And we have also studied that resistance is directly proportional to length. Right? Resistance is directly proportional to length. So the resistance of this wire is already given as R1. If the length is divided by 5, what happens to the resistance? Since they are directly proportional, what happens to the resistance? Resistance will also get divided by 5, right? So we will get the value of resistance as R1 by 5. R1 by 5, because since we have 5 equal pieces, we will get each piece equal to, the resistance of each piece equal to R1 by 5. Keep in mind this particular point, because we know resistance is directly proportional to the length. The total resistance is given and the wire is cut into 5 equal parts. So if the length is divided into 5 equal parts, then the resistance will also get divided by 5. Okay. Now we have 5 resistance. Okay, 5 resistance, and they have given that they are connected in parallel. And they are connected in parallel. So when they are connected in parallel and the resultant resistance of this combination, that means when we are connecting this 5 resistance in parallel, the resultant value what we get is R2. Okay, the resultant value what we get is R2. So we know that the equation when resistance are connected in parallel, what is the equation we know? We know 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. Right? Since we have 5 resistance here, this will be our equation, right? So what is the value of this total resistance given? It is given as R2. So we can write 1 by R2 is equal to 1 divided by what is R1? R1 is R1 by 5 plus R2 is also what? R1 by 5 plus 1 by R1 by 5. Again plus 1 by R1 by 5. Again plus 1 by R1 by 5. Okay, so what you will get? You will get 1 by R2 is equal to 5 by R1 plus 5 by R1 plus 5 by R1 plus 5 by R1 plus 5 by R1, which is equal to 25 by R1. This 5 by R1, how you are getting it? When you are taking the LCM. So this comes 5 plus 5 plus 5 plus 5 plus 5, 25 by the common denominator R1. So I'll write the balance here. So we got 1 by R2 is equal to, 1 by R2 is equal to what? 25 by R1. What you need to find out? You need to find out the ratio of R1 by R2. So how can you write R1 by R2? So R1 by R2 will be equal to what? 25. R1 by R2 is equal to 25. So hope this is clear. So I'll explain it once again. So given that we have a wire of resistance R1 is cut into 5 equal pieces, and these 5 pieces of wires are connected in parallel, and the resultant is R2. You need to find what is the ratio between R1 and R2. So here we are considering the length of the wire as L. So since it is cut into 5 equal pieces, each piece will be L by 5. And we know resistance is directly proportional to length. So if the length is divided by 5, then the resistance value will also be divided by 5, obviously, right? So we have 5 resistors, each value is R1 by 5. So resistance, and they have given they are connected in parallel. So we know the equation is 1 by RT is 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. Since we have 5 resistance here. So how can I write 1 by R2? Because it is given that the resultant resistance of this combination is R2. So I have written it as 1 by R2. Instead of RT, I have written 1 by R2. And we know R1 is R1 by 5. All the values of resistance are same. So R1 by 5, R1 by 5, R1 by 5, R1 by 5. Taking the reciprocal of 1 divided by R1 by 5 will get 5 by R1. So adding all this will get 25 by R1. So 1 by R2 is equal to 25 by R1. We need to find out R1 by R2. So R1 by R2 is equal to 25. Okay. Fine. We'll move on to the next question. Okay. So given 2 resistors are connected in series, it gives an equivalent resistance of 10 ohm. When they are connected in parallel, gives 2.4 ohm. Then find the value of individual resistance. Okay. So let us find out. So what you have to find is you need to find out what is the value of both the resistance. So the data given is when they are connected in series. So when these 2 resistors R1 and R2 are connected in series, the equivalent resistance is 10 ohm. So what does it mean? R1 plus R2 is equal to 10. Correct? So similarly, they have given that when they are connected in parallel, what is the equivalent resistance value given? They have given that 1 by R1 plus 1 by R2 is equal to 1 divided by 2.4. Because when they are connected in parallel, the value is 2.4. So 1 divided by 2.4. Okay. Now you need to find out what is the value for R1 and R2. Okay. So let us take this as the first equation and this as the second equation. So let us consider equation 2. Okay. So what is equation 2? 1 by R1 plus 1 by R2 is equal to 1 by 2.4. Or if you are cross multiplying this two, what you will get? R1 plus R2 divided by R1 R2 equal to 1 divided by 2.4. I am just cross multiplying these two terms. Or I can write R1 R2 divided by R1 plus R2 is equal to 2.4. I have just taken the LCM, reciprocal. R1 R2 divided by R1 plus R2 is equal to 2.4. Now, we know that R1 plus R2 is what? 10, given in the question, right? So, we can write R1 R2 divided by 10 equal to 2.4. Okay, or what will I get? R1 R2 is equal to 2.4 into 10. What is that? 24. Okay, or I can, from this I can write R1 is equal to 24 divided by R2. So, let this be the third equation. Okay. Is this clear? So I'm just cross multiplying this. I'll get R1 R2 is equal to 24, and R1 is, if I'm finding an equation from this R1, so R1 is 24 by R2, right? Now what I'm going to do is I'm going to substitute equation 3 in equation 1. Okay, so I have equation 1 as R1 plus R2 is equal to 10. So instead of R1, I am going to substitute the value. So equation 3 is what? Equation 1 is what? R1 plus R2 is equal to 10. So I am going to substitute equation 3 in this. So instead of R1, what I can write? I can write 24 by R2 plus R2 equal to 10. Right? Instead of R1, I am going to write 24 by R2 plus R2 is equal to 10. So just multiply these terms. So what you will get? 24 plus R2 into R2 is R2 square divided by R2 is equal to 10. Taking the LCM. 24 plus R2 square divided by R2 is equal to 10. Or I can write 24 plus R2 square is equal to 10 into R2. Now rewriting this equation, R2 square minus 10 R2 plus 24 is equal to 0. Okay, R2 square minus 10 R2 plus 24 is equal to 0. Now I need to factorize this one. So, I think you all know how to factorize, right? So, when I am multiplying, I need to get the value 24, and when I am adding, I need to get the value minus 10. So, minus 10, so I can write minus 6 and minus 4, right? Minus 6 plus minus 4 is equal to minus 10, and if I am multiplying it, I will get it as positive 24. So, this satisfies. So, how I can write R2 into what it will be? Yes, R2 minus 6 into minus 4 into R2 minus 6 is equal to 0. Or you can just write R2 minus 6 into R2 minus 4. R2 minus 4 is equal to 0. Or you will get the value for R as 4 ohm and 6 ohm. Okay, so either R1 can be 4 or R2 can be 4, whatever it is. So the value for resistance are 4 ohm and 6 ohm. So I think this is clear. So I'll explain it once again. So what is given in the question is two resistors are connected in series. It gives an equivalent resistance of 10 ohm. That means when two resistors are connected in series, I'll get a value as 10. That is R1 plus R2 is equal to 10. Same resistors, when they are connected in parallel, the value is 2.4. So I'm connecting in parallel. So 1 by R1 plus 1 by R2 is 1 by 2.4. So from this equation, I'm just considering the equation 2. 1 by R1 plus 1 by R2 is equal to 1 by 2.4. I'm just cross multiplying these two. So I will get R1 plus R2 by R1 R2 is equal to 1 by 2.4. Or if I am taking the reciprocal of this term, I'll get R1 R2 by R1 plus R2 is equal to 2.4. Now look into this term R1 plus R2. I already have the value for R1 plus R2 as 10. So I'm substituting the value here, and if I'm multiplying it with 2.4, I'll get as R1 R2 is equal to 24. From this I am finding a value for R1. So R1 is equal to 24 by R2. Now I am going to equate this value. I'm going to substitute this value in equation 1. R1 plus R2 is equal to 10. So R1 plus R2 is equal to 10. Instead of R1, I am substituting 24 by R2 plus R2 is equal to 10. So if I am cross multiplying, taking the common LCM, I'll get 24 plus R2 square by R2 is equal to 10. Multiply, I'll get 24 plus R2 square is equal to 10 R2. So here it forms a quadratic equation. Finding the common factors, I'll get the value for R is equal to 4 ohm and 6 ohm. Okay, so that is all for today. So this is all the numericals based on the parallel connection. So this numerical is a very important. This one and this one we have discussed right now are very important equations and very important type of problem. Okay, so hope you all understood it. Thank you all for watching. We'll catch you in the next video. Till then, take care. Bye bye.